Greeting learners, welcome to Science Academy. In this lesson, we will learn how to estimate surds. If the nth root of a number cannot be simplified to a rational number, we call it a surd. For example, we are given the square root of 2. If we punch square root of 2 in the calculator, realize that we will get 1,441,2,136,237. So realize that this answer is not a rational number, but it is a decimal, which means that this is a surd because it did not give us a rational number. Moving on to the next example, which is the cubed root of 6. If we simplify the cube root of 6, we will get 1,817,120,5,9,283. Realize again that this is a decimal, not a rational number. So which means that the cube root of 6 is a surd because it did not give us a rational number. Let us look at the last example, which is the square root of 4. If we punch square root of 4 in our calculator, we will get 2. So realize that 2 is a rational number, which means that the square root of 4 is not a surd. So in this lesson, we will look at surds of the form n root a, where a is any positive number. A can be 1, it can be 2, it can be 3, it can be 4. So a is any positive number. It is very common for n to be 2. And in the case where n is 2, we don't need to write the 2 here. We will just have to write this sign and our a. If we see a surd with this sign and a only, we know automatically that there is a 2 here. It is sometimes useful to know the approximate value of a surd without having to use a calculator. For example, we know that the square root of 3, it gives us 1,732,080,757. So if we punch square root of 3 in the calculator, we will get this decimal. And it is easy to see that this decimal over here, it lies between 1 and 2 in the number line. So square root of 3, it lies between 1 and 2. It's easy for us to see. But now, in the case where we have surds like square root of 18, without using a calculator, it will be very difficult for us to detect where the square root of 18 lies in our number line. So if we have a and b as our whole numbers, and a being less than b, this simply means that the nth root of a will also be less than the nth root of b. So here is an example to explain this concept. Supposing you are given 1 as our a and we are given 2 as our b. Realize that 1 is less than 2. So which means that if we get square root of 1 will will be less than square root of 2. So this is what the concept means. A perfect square is a number obtained when an integer is squared. For example, if we square 1, we will get 1 as our perfect square. If we square 2, we will get 4 as our perfect square. If we square 3, we will get 9 as our perfect square. If we square 10, we will get 100 as our perfect square. So a perfect square is any number obtained when you square an integer. So that is a perfect square. Moving over. Similarly, a perfect cube is a number which is the cube of an integer. So this simply means that if we have an integer 3 as our example, 3, if we cube this integer, we will get a perfect cube 27. So 27 is our perfect cube because it is obtained by cubing an integer. Another example is the cube. If we cube 2, we will get 8 as our perfect cube. Let us look at the last example. It is 4 cubed. If we cube 4, we will get 64. So this also is our perfect cube. So consider the set cube root of 52. It lies somewhere between 3 and 4. Why? Because the cube root of 27, it gives you 3, and the cube root of 64, it gives you 4. So this means that the cube root of 52, it lies between 3 and 4. Or you can say it lies between 27 and 64. Moving over. So here are a few examples of sets. We have as our first example 4 square root of 7. If you punch 4 square root of 7 in your calculator, you will get a decimal and not a rational number. Remember from the first slide we have learned that this is a set because if we punch it, if we simplify it, we get a decimal but not a rational number. But if it gave us a rational number, it will not be an example of a set. So the next example is 6 square root of 2. If you punch 6 square root of 2 in your calculator, you will get a decimal and not a rational number, which means that it is a set. If you punch 3 square root of 7 in your calculator, you will get a decimal as well. You will not get a rational number. So, which means that it is also an example of a set. If you punch 8 square root of 2 in your calculator, you will not get a perfect square, but you will get a decimal, which means that this 8 square root of 2, it is a set and not a perfect square. Moving over, and here are examples of perfect squares. If you square 1, it gives you 1. If you square 2, it gives you 4 as your perfect square. If you square 3, it gives you 9 as your perfect square. If you square 4, it gives you 16 as your perfect square. If you square 5, it gives you 25 as your perfect square. If you square 6, it gives you 36 as your perfect square. If you square 7, it gives you 49 as your perfect square. So these here are examples of perfect squares. So realize that if you put a perfect square under a square root, it gives you a rational number, it gives you a rational number. For instance, if you put 1 under a square root, it gives you it gives you 1 as your rational number. If you put 4 under a square root, it gives you 2 as your rational number. So from here we see that if we put our perfect squares under the square root, it gives you an integer. Moving on to the next slide. So here is an example which says that find 2 consecutive integers such that the square root of 26 lies between them. Remember that consecutive integers are 2 integers that follow one another on the number line. For example, 5 and 6. 5 and 6, they follow one another on your number line. And another example is 8 and 9. 8 and 9 follow one another in your number line. So these are the 2 examples of consecutive integers. So we must now find between which 2 consecutive integers the square root of 26 lies. So let us tackle this example. So let us list first our perfect squares. So if you square 1, it gives you 1, and if you square 2, it gives you 4. Remember, we need to find 2 consecutive integers which the square root of 26 lies between. Continuing, if you square 3, it gives you 9, and if you square 4, it gives you 16. If you square 5, it gives you 25, and if you square 6, it gives you 36. So from this, realize that if you remember from the previous slides, we have learned that if you square a perfect square, it will give you a rational number. It will give you an integer. So if you square 25, it will give you 5, and if you square 36, it will give you 6. So realize that from this, realize that the square root of 26, it lies between the square root of 25 and the square root of 36. Remember, the square root of 25, it gives you an integer 5, and the square root of 36, it gives you an integer 6. So we can write it this way. So the square root of 26 is between the square root of 25 and the square root of 36, which means the square root of 25 is less than the square root of 26 26, and the square root of 26 is less than the square root of 36. So this simply means that the square root of 36, it lies between 5 and 6. Remember, square root of 25, it gives you 5, and square root of 36, it gives you 6. So these are the 2 consecutive integers which the square root of 26 in your number line lies between. Moving over. So this is just the solution to the question. So here are other questions. Let us tackle a few of these questions. Let us read the first question. It says that determine between which 2 consecutive integers the following numbers lie without using a calculator. So just as we have done in the previous example, we will have to list some few perfect squares. If you square 1, you will get 1 as your perfect square. If you square 2, you will get 4 as your perfect square. If you square 3, you will get 9 as your perfect square. And if you square 4, you will get 16 as your perfect square. Remember, the first example is square root of 18. We must now we must now determine we must now determine between which 2 integers does the square root of 18 lies. Let us continue here. If you square 5, you will get 25. So realize that if you put a perfect square under a square root, you will get an integer. So the square root of 16 will give you 4, and the square root of 25, it will give you 5. So realize that 18, square root of 18 is between the square root of 16 and the square root of 25. So we can also write this as 18 is between the square root of 16 and the square root of 25. Realize that the square root of 16, it gives you 4, and the square root of 25, it gives you 5. So the two integers, the two consecutive integers which the square root of 18 lies, it is 4 and 5. So we are moving over to the next question. Let us do I over here. It's more challenging. So it says that we must find between which two consecutive integers does the square root, the cube root of 90 lies. So first of all, we will have to get our perfect cubes. Remember, we have learned that a perfect cube is any number you obtain by cubing an integer. So if we cube an integer 1, we will get 1 as our perfect cube. If we cube an integer 2, we will get 8 as our perfect cube. And if we cube 3 as our integer, we will get 27 as our perfect cube. And so if we cube 1, we will get 1. If we cube 2, we will get 18. If we cube 3, we will get 27. So if we cube 4, we will get 64 as our perfect cube. And if we cube 5, we will get 125 as our perfect cube. So realize that if we cube 64, if we cube any perfect cube, we will get an integer. So realize that in this case, if we cube 64, we will get 4 as our perfect cube, or as our integer. And if we cube 125, we will get 5 as our integer. So now this tells you that the square root of the cube root of 90, it lies between the cube root of 90, it lies between the cube root of 64 and the cube root of 125. So realize that the cube root of 64, it is 4, and the cube root of 125, it is 5. So the two consecutive integers which the cube root of 90 lies between is 4 and 5. So let us move over to our last question here. Let us choose h. So h it says that we must determine between which two consecutive integers does the cube root of 125 lies. So cube root of 123, sorry, not 125, but 123 lies. From the previous example, from the previous question, we have learned that if we cube 5, we will get 125, and if we cube 4, we will get 64. So the cube root of 125, it gives you 5, and the cube root of 64, it gives you 4. Which means that the cube root of 123, it lies between the cube root of 64 and the cube root of 125. So realize that again the cube root of 64, it gives you 4, and the cube root of 125, it gives you 5. So the cube root of 123, it is between the integer 4 and the integer 5 in your number line. So we will leave the rest of the questions for you to tackle. We thank you so much for viewing this video, and we thank you so much for liking our Facebook page. Thank you.